Integration by substitution. In the syllabus it states that a candidate should be able to understand integration as the reverse process of differentiation and integrate in brackets ax plus b all to the power n for any rational n except -1, together with constant multiples, sums and differences. In the first example we have the integral of 2x cubed minus 5x plus 1 in brackets. However, that can be written without the brackets. And this type of integration is done using the rule that the integral of ax to the n is ax to the n plus 1 over n plus 1. So when we integrate the function, the 2x cubed becomes 2x to the 4 over 4, the minus 5x becomes minus 5x squared over 2, and the plus 1 becomes 1x, but we must, as always, remember to add a c. Now in the second example we've got the integral of 1 over 2x plus 3 in brackets squared dx. Now in this case the brackets can't be left out, so we have to use the reverse of the chain rule, which is called integration by substitution. Now, you may need to integrate an equation that looks like the integral of ax plus b all to the power n dx, where a, b, c and n are written as numbers where n is not equal to -1. Here we cannot leave out the bracket. So let's look at an example. Work out the integral of 7x plus 3 all to the power 5 dx. Now to solve this, we make what's called a substitution. The 7x plus 3 is written as a single letter. So let u equal 7x plus 3. Now we can differentiate. So du by dx is equal to 7. Now if we multiply both sides by dx, you get du equals 7 times dx, and if you divide both sides by 7, you get 1/7 du equals dx, or dx is equal to 1/7 du. Now we can make a substitution. In the original problem we had the integral of 7x plus 3 all to the power 5, and this becomes the integral of u to the power 5. We've also got dx. Now we can substitute that as 1/7 du. So this becomes the integral of 1/7 u to the power 5 du. To integrate u to the power 5, that becomes u to the power 6 over 6. So we've got 1/7 times u to the power 6 over 6 plus c. Remember, we must always add c in. Now on the bottom we can multiply 7 times 6 to give 42, and on the top u to the 6 becomes 7x plus 5 all to the power 6. So our answer is 7x plus 5 all to the power 6 over 42 plus c. Remember, always we must add an arbitrary constant. Now in the second example they've given, we've got the integral of 1 over 2x plus 3 all squared dx. And we're going to make the substitution u equals the thing in the bracket. So u equals 2x plus 3. Now if we differentiate that, we get du by dx is equal to 2. So if we multiply both sides by dx, we get du equals 2 dx. And if we divide by 2, a half du equals dx, or dx is equal to a half du. Now when we substitute that, we get 1 over 2x plus 3 squared becomes 1 over u squared, and dx becomes a half du. So now we've got 1 over u squared can be written as u to the -2 du. And we can integrate that. When we integrate u to the power -2, the -2 increases by 1, so that becomes -1, and we divide by that number, so we divide by -1. So we have a half times u to the -1 over -1, but we must remember to add the c, which can be written as -1/2 u to the power minus 1 plus c, which is minus a half times 1 over u plus c, or minus 1 over 2 into 2x plus 3 plus c. And if we multiply out the brackets, that gives us minus 1 over 4x plus 6 plus c. Now there follows an exercise of 5 questions. You can pause the video at this point and have a go at them yourself. When you've tried them, you can restart the video and I'll go through the answers. Okay, let's see how these are done. In the first one, we have the integral of 3x minus 5 all to the power 7 dx. So we're going to replace what's in the bracket with a single letter. So let u equal 3x minus 5. Now if we differentiate both sides, that gives us du by dx is equal to 3, or multiplying by dx we get du equals 3 dx. We can divide both sides by 3 and we get dx is a third du. Now we can substitute those into the original equation. The 3x minus 5 all to the power 7 becomes u to the 7, and the dx becomes 1/3 du. So we need to integrate 1/3 times u to the 7 du. Now when we integrate u to the 7, that becomes u to the 8 over 8. So we have a third times u to the 8 over 8 and plus c. We must always remember to add a constant at the end. So this gives us u to the 8 over 24 plus c, and now we can substitute back the u for 3x minus 5. So this gives us 3x minus 5 all to the power 8 over 24 plus c. In question 2, we're asked to integrate minus 7x plus 2 all to the power 4 dx. Again, let the expression in the bracket be represented by a single letter. So let u equal minus 7x plus 2. Now if we differentiate, we get du by dx is minus 7, and if we multiply both sides by dx, we get du equals minus 7 dx. We can then divide both sides by minus 7, and that gives us dx equals minus 1/7 du. Now, if we make the substitution, the minus 7x plus 2 all to the power 4 becomes u to the power 4, and the dx becomes minus 1/7 du. And so we have the integral of u to the 4 times minus 1/7 du, or the integral of minus 1/7 times u to the 4 du. Now when we integrate u to the power 4, it becomes u to the power 5 over 5. So our integral is minus 1/7 times u to the power 5 over 5 plus c. And we can simplify that to be minus u to the 5 over 35 plus c. And if we substitute back u as minus 7x plus 2, we end up with the integral is equal to minus 7 plus 2 all to the power 5 over 35 plus c. Now in number 3, we're asked to integrate 3x plus 6 to the power 1/2 dx. Again, let the expression inside the bracket be represented by a single letter, so u equals 3x plus 6, in which case du by dx is equal to 3, and if we multiply by dx, du equals 3 dx, or dx equals 1/3 du. Now if we make the substitution, 3x plus 6 all to the power 1/2 becomes u to the 1/2, and dx becomes 1/3 du. So we're integrating 1/3 times u to the 1/2 du. Now when we integrate u to the 1/2, the power increases by 1. So that becomes u to the 3 over 2, and we divide by that number 3 over 2. So that gives us a third times u to the power 3 over 2, and instead of dividing by 3 over 2 we can multiply by 2 over 3 plus c. So this gives us 2u to the power 3 over 2 all over 9 plus c. Now this can be written as 2 times the square root of u cubed all over 9 plus c. So when we substitute it back, we get the integral is equal to 2 times the square root of 3x plus 6 all cubed all over 9 plus c. Or we could write that as 2 times the square root of 3x plus 6 all cubed all divided by 9 plus c. In number 4 we have the integral of 8 over 5x minus 3 all cubed dx. Well, let u equal what's in the brackets, so u equals 5x minus 3. So if we differentiate, du by dx is equal to 5. So du is 5 dx, and if we divide by 5, dx is 1/5 du. Now if we substitute, the 8 over 5x minus 3 cubed becomes 8 over u cubed, and the dx becomes 1/5 du. Now we can write 1 over u cubed as u to the power minus 3. So we have 8 over 5 times u to the power minus 3 du. Now when we integrate u to the power minus 3, the minus 3 is increased by 1, so it becomes minus 2, and we divide by minus 2. Remember, we must add on c. So now we've got minus 8u to the minus 2 over 10 plus c. Now the 8 and the 10 cancels, and u to the minus 2 can be written as 1 over u squared. So that's equal to minus 4 over 5u squared plus c, and we can replace the u with 5x minus 3, and so we have the answer. The integral is minus 4 over 5 into 5x minus 3 all squared plus c. Now in question 5 we're asked to integrate 1 over the square root of 2x minus 1 dx. Now again we can let u equal the expression inside the square root, so u equals 2x minus 1, and if we differentiate, du by dx is equal to 2, so du equals 2 dx, or dx is a half du. Now if we substitute, the 1 over the square root of 2x minus 1 can become 1 over the square root of u, and the dx becomes a half du. Now 1 over the square root of u could be written as u to the minus a half. So we have the integral of a half times u to the minus a half du. Now when we integrate u to the minus a half, the minus a half is increased by 1, so it becomes plus a half, and then we divide by a half. So we have a half times u to the half divided by a half plus c. Remember to add c. Now instead of dividing by a half, we can multiply by 2 over 1. So that gives us a half times u to the half times 2 over 1 plus c. Now the half and the 2 over 1 cancel, so that gives us u to the power a half plus c. Now u to the half plus c can be written as the square root of u plus c. So when we substitute back, we get our integral is equal to the square root of 2x minus 1 plus c.